Be miles away from it, and you just notice the horizon goes slightly up and then slightly down again. And it covers hundreds of square miles, and it's a big shield volcano. And these are very typical locations for lava tubes. What we have here is when that lava left the lava river here, the roof was still a little bit plastic. It wasn't completely frozen yet, and it dipped. The whole thing just kind of sank. In other places here, it collapsed. These collapses happen when that lava withdraws. If it's not strong enough to hold itself up, it collapses. Most of the collapse in lava tubes happens right at that period when the high dynamic stress is applied to them. Anything that survives this, the drainage of the lava and the cooling of the lava tube, tends to stay around for a long time. If I turn around from that last picture from where I was, Cheryl, why don't you handle focus on this? It seems to
I'll
change it a little bit. Or Tom, thank you. Oh, this is Tom Billings, another one of our researchers here. You still see a sign of that dip here in the top of that lava tube, but here it's thick enough that it held up. And there's a short lava tube inside there. And as you see, this lava trench leads up to a lava tube. So that's an important point to get to. This is another area on the side of the Medicine Lake volcano. This is not the center of the Medicine Lake volcano. This is over on the flank where there was a large eruption that created some large lava tubes. And this is called Mammoth Crater. We're looking down into the bottom of the crater there. And those are full-size trees, so you can get some idea of what size this crater is. Coming out of that, we get lava channels such as this one, for example. Can you take a few sheets of paper out from underneath that and lower the picture a little bit? Think about a dozen. A little more.
Keep on. A little more.
Don't be shy now.
Ready? A little more.
If you want to do a little bit more, we can handle it. Okay, that's good. Anyway, and you see here our standard researcher standing at the side, and the lava tube cave here, and you can get some idea of the roof of the lava tube there. I'm actually going to go over to a different lava tube here to show you looking down inside a lava tube. Once again, our standard researcher, who happens to be Tom Billings, our photogenic model, is, you see the opening on the top actually leads into a much bigger cave inside. So even if the opening looks small, it can lead to something quite large. And here's taken from inside. You can see the collapse opening area. You can see trenching here that lava has actually dug down into the original cave during later eruptions that eats down into the floor and that sort of thing. The Indians use these caves, and with this area, which is in Lava Beds National Monument in Northern California, just up by the North California border. Excellent collection of lava tubes. If anybody wants to travel out there sometime, I recommend summertime, not winter. Some of them have these pictographs on them. Unfortunately, nobody knows what they refer to or what they mean because the knowledge has been lost over the years. And in fact, one of the last Indian wars occurred in a lava field, with lava tube caves and other lava formations being important to that war. And that was the Modoc Indian War at the Klamath Falls, Northern California boundary area. A small band of Modoc Indians was able to hole up in this exact lava territory where we are here for some time and hold off the entire U.S. cavalry with armament, with their simple tools and determination.
Depending on how you look at the start of hostilities, anywhere between 3 and 18 months.
And they killed the commander.
Yes.
That was against a force that had artillery.
Yes.
Right.
So the Modoc, what's left, all three of them who are left are now in Oklahoma, I believe. They finally couldn't withstand the forces, but they held out for a long time because of the terrain they were in. Lava tubes come in all shapes, and this is one of the smallest ones that we found, actually. Cheryl can probably fit in the beginning of this, but she couldn't squeeze through to the other end. So as you see, they can be quite large or quite small. I figured you might be curious. This is the top of the volcano. This is the caldera in the top of the Medicine Lake volcano. And what happens is the lava comes up in the middle of this volcano. It finds a weak point somewhere in the flank of the volcano and comes out in these big pores of lava that make these lava fields and the lava caves and such. And that empties out the lava chamber underneath the volcano. And as that chamber gets emptied, the top can't hold, so the top of the volcano falls into the chamber and forms this large caldera, crater-like hole there. It did not erupt from the caldera, although it can. Anyway, it's a popular recreation site. I don't know how many people who use it realize what sort of a violent past it's had. Another thing you find a lot of times in these things is obsidian flows. And that's this unusually lumpy gray flow where nothing much grows back here. That entire section is glass, almost pure glass.
When you see it by eyeball, it glitters.
Right. That's Mount Shasta in the background there for anyone who'd like a perspective on things. And here's a closer up of it, and you see the sun just shines off of those sharp glass facets and surfaces of these glass boulders that fall down the side. The Indians prized obsidian glass for knives and arrowheads and that sort of thing. And in fact, ophthalmologic surgeons today still use obsidian glass knives because of the ultra-fine point that they make to cut for cornea transplants, things like that.
Single molecule edge.
It's about theoretically as sharp as you can get. Traveling up to the Oregon Cascades, this is a small lava tube that's located more or less in the middle of the Cascade Range. It shows a couple of features, well, 3 if you count tourists. You have the walk-in entrance down here, and you also have a skylight entrance back here. And we'll see in a moment this group of people, as they walk under the skylight, are illuminated inside the cave by the light coming from up above. Get a little deeper in the cave, and this one is not any particularly remarkable, but since we're just exploring different lava tube caves, this is what it looks like. It's kind of rough, blocky, and in places it can get quite tight. Interesting thing about these is even though they're flow formed, there are areas in a lava tube that can be quite tight and a squeeze, and they will open up to an area that's much larger on the other side. This is another thing to kind of play tricks on your mind with scale. I had to lean down and poke the camera through a tiny hole in the ground to get this picture, and that's a cigarette. So the shapes of these lava tubes are sort of scale independent, whether they're really large or really small. Some lava tubes are formed in such a way that they collect cold air during the winter, say. It just falls into them like a funnel. And the basalt is a really excellent insulator. So later on, when it warms up outside, the cold air stays down in the cave, and liquid water coming in through cracks or into the entrance will come down into the cave and freeze. And you'll get formations like you'd expect to see in a limestone cave, except they're made out of ice. And we'll touch on the ice formation in caves in the next presentation. Here's another example of ice that comes in and freezes in sheets. So it like poured in through the entrance and then froze when it got to the cold air. And you can see the layers where it's cut away there. That last cave was in New Mexico, by the way. In case you're curious, this is a close-up of a lava tube ceiling. And you can see that it's cracked. It's not naturally sealed usually because the basalt itself cracks as it cools. However, this does not necessarily damage the integrity of the cave. Some of these cracks go through the entire basalt sheet that the cave is in, and it just sits there. It doesn't hurt the cave. Might focus that just a little bit, actually. Might be hard for you to tell. But. Now, on terrestrial caves, in some places you get these deposits. They seem to be related to water seeping through and being held on the cold surface of the cave, where the cold cave air cools it off and condenses water, and the minerals come out of it. And our understanding from a geologist friend of ours is that this white crust on this cave is actually opal. It's not jewel grade by any means, but it's the same stuff as opal, just out in thin deposits like this. You can tell some things about air circulation in the caves by where these deposits form. Here's a cave. It's one that we used in our studies with young astronauts in Central Oregon. We took young astronauts and actually did lunar-based simulations in these caves to see how it would work, if there'd be any showstoppers. And in fact, there were some problems, but there were no showstoppers. The two biggest problems we had were the dust. It turned out was a really bad problem, and it caused us to take a new look at lunar dust as a problem. And it's a problem because it's abrasive, it makes parts stick together, it's electrostatic, so it's attracted to your faceplate, your glasses. It's also attracted to electrical circuits, switches, plugs, and it's an insulator, so that doesn't help much.
The gears and cameras.
And some people have a little trouble breathing when they get an atmosphere full of that stuff. And it's very fine, so it's very hard to filter. At any rate, the other problem we discovered was actually boredom. A lava tube, once you get over the initial gee whiz of it, is pretty plain and boring place. It's a tube of lava that's black. So there you are. And having the kids to work with was a really big help because they wouldn't put up with it. An adult crew would have said, oh, these guys, you know, they're trying hard. We can put up with this for a weekend. Kids, 20 minutes. You know, that's it. If you haven't got something for us, we're out of here. So we learned the value of entertainment, and we think that's going to be very important for working on the moon and Mars and other extreme environments. You need a way to relax and get your mind off of work and do something different, more interesting. At any rate, in this cave, we got down through a ladder and a skylight entrance. I'm going to show you some cave features. Here's another section of the cave. Shows you what we call breakdown on the floor. There's things you can look for that are kind of interesting. In some caves, you can find breakdown on the floor, but the ceiling is perfectly smooth. What happened there? We're not sure, actually. We think maybe a later flow broke up and made that bottom batch of blocky basalt, and actually didn't have anything to do with breaking down from the ceiling. In other cases, you might look at the ceiling and find a place where it looks like maybe there's breakdown, should have been from right up there. But when you look down on the floor, not in this picture, but in others, there's nothing there. Where did it go? In that case, the breakdown probably occurred while lava was still flowing in the cave, and the lava stream carried the breakdown away, and it's deposited it somewhere else in the cave. Here's an example of that. It's very hard to see, and maybe we should try to turn out all these lights now that I think about it. But we don't have too many slides this dark. Cheryl is standing on a chilled lava pool. There we go. She's standing on a chilled lava pool from the lava flow itself, and her foot is resting on a rock that was floating in that pool when everything froze solid. So here's an example of that breakdown being carried away by the lava, and it's actually just frozen in motion here as a demonstration. This cave is one of the Medicine Lake volcano caves down at Lava Beds National Monument. Now we're back up in Oregon. When you get a cave on a very flat surface at near 0 degrees slope, and incidentally, most of these caves exist on slopes that are no more than about 7 degrees, usually much less. So you have a very narrow range of degrees here. I think that when you get a steeper area, the lava flows too fast to cool and form a roof on it, and it just runs out. But here we have nearly 0 slope, and so the lava tends to brachiate, to branch out and go in different directions and meander and not quite know where it's going to go. And we have a case of that here where the lava has gone in 2 directions. Behind me, from where I'm taking the picture, and then in these 2 directions. And in fact, this direction over here attaches to an entirely parallel lava tube cave, almost the same size as this one, in fact, a little bigger. In fact, that hole comes through right there, which is a tight crawl, believe me. And the salt does not give as you crawl through it. We have our standard researcher for scale here, that's Tom. And a little pile of breakdown, interestingly enough, right in the same area where this pass-through occurred. If you spend some time in these, you can construct quite a history of development. Uh-oh, that slide died. That was the last slide that didn't feed right. There we go. It's still not fed right, but I'll say that's our base research team there, standing in the middle of the subway portion of our main research cave in Central Oregon. So,
Well,
a few
there's
minutes.
something important to say about this.
Okay, say about it.
No, excuse me, not this one, I'm sorry.
Not this one?
Recognizing.
No, don't do that, Tom. Don't
Don't do that?
Just, in fact, just put the slide up.
Over each slide.
Oh, that was worse. Just get it out of the hole there in front of that slide's coming apart. So, any questions? Just turn out the light there. for
That
the
floor,
moment.
that last thing that you showed, was, what was that texture of that floor?
That floor was sand and dust, and it gets washed in during periodic extreme rain shower floods and settles into that cave, and it's very level. It's about 3 or 4 feet deep in that section of the cave. We've done some soundings on it as part of the NASA study. We had our geologist, Steve Gillette, take a look at that dust and sand, as a matter of fact. He took it into his lab to an electron microscope. And he found that the sand grains had particles of dust all over them. They were like, powdered sugar, dust all over it. So he zeroed in on one of those little dust particles, and he found that that little dust particle had little bitty dust particles all over it, just like powdered sugar. And he zeroed into one of those dust particles, and he found that particle was splitting apart, making little bitty dust particles all over it. And it was just incredible, and it illustrates the kind of problems that this dust can be. You can't really appreciate it from a macro scale, but this very fine micro scale has all sorts of strange effects. Yeah.
If the transport mechanism of the dust was wind and running water, do you expect there to be that much dust inside of a lunar lava tube where there's no wind or running water?
Good question. As a matter of fact, except where there's been a breach in the roof or right near the entrance, we would expect lunar lava tubes to be free of lunar dust, and that's one of their big advantages, because they'll be plain. You saw that floor that Cheryl was standing on earlier, that flat lava floor.
Mm-hmm.
There's no dust in there. That's one of the Northern California caves, and once you get a few feet within the entrance, there's no more of that dust at all in that cave, and that would be the normal case.
T.D. Lynn was talking about making cement this morning, did an electron microscope scan of lunar regolith,
Sample.
and it had little tiny dust particles. And when he tried to wash it off with alcohol, they didn't come off, they were sintered on.
Mm-hmm.
So did Steve do any sort of washing to see if those dust particles were attached, or if they were all loose?
He's at this conference.
You can ask him. As a matter of fact, he's next door.
Oh, okay.
Yes,
I'll ask
We'll put him together with you.
I don't think he did. That was not part of our contract request with him. This was done under subcontract to a NASA contract we had to simply characterize the site. But our experience in being able to kick up the dust in the cave indicates that it can definitely be separated from the sand. It gets up in the air all the time.
Ultra painful.
Yeah, and there'll probably be dust like that in the Mars caves, some of them.
Mhm.
One reason our test cave had so much of this, though, was it was directly downwind from the Mount Mazama explosion. That's the time the mountaintop blew off and created Crater Lake in Oregon. And it was buried in about 3 feet of volcanic ash, which is very fine glass flour dust stuff. So, how are we doing? Any more? How timely. It's about time to start the second half of the show. Did you have a question?
Have you guys tried to take any rovers or robots or carts through these things to see how hard it is to navigate one?
We haven't gone into the caves with one, but we actually did have an experimenter, an engineer from Rockwell, with a rather interesting design for a lunar outpost construction robot cart that he worked up in his garage. Getting very hard to get Rockwell to fund some things sometimes. And he had some problems with it because it turns out, as an aerospace engineer who worked on the shuttle, he did not have experience in designing augers to dig into the earth. And his design for an auger to stabilize his little vehicle was inadequate to the task. However, we were able to bring out some geologists who were experienced in augering holes in the earth, and they met up with him and we did some experiments. He tried some other things with his cart. And in fact, we had a very productive session, and he learned a lot because our team was able to bring together these eclectic experts from different fields to talk to each other about this new problem of exploring on another world. So, yes and no. We'd like to do more of that stuff, actually. If you have any you'd like to bring out, we can make arrangements.
Have you been to Government Cave in Arizona or up around Flagstaff, any of those sites?
Haven't been there. I've been to a little ice cave on Sunset Crater before.
That one's mean in Arizona?
Yeah.
Sunset Crater, okay.
Yeah.
Yeah. They've closed that one off. We can't get to that one anymore.
I'm an old man. It wasn't closed when I went.
Supposedly there's one behind that that's open, but it's much harder access road to get to, and it's
Yeah.
smaller. And then there's a whole bunch more out in the woods, but you can't, you've got to start presenting your credentials before people will tell you where they are.
I believe you. And that's an example, though, that where you find one of these, you're liable to find more. Because where the conditions are right to form one, there's usually others around, but you sometimes have to look for them. Finding them, now that can be a problem.
They usually are found by what they call the broken leg method. Yeah, Lava Beds National Monument, if I recall correctly, has 30-some
Billings.
open to the public caves.
Remove the
Um,
slide projector.
But there are
Maybe it's
literally hundreds just
Just don't
within
leave the slides on it.
the National Monument
Don't leave
area
the slide
of
projector.
lava
To
tubes.
use it.
Just most of them aren't marked or publicly open.